Because it's 300. Without ALOHA. Even though fifth one.
At the moment.
Okay. Yeah, come over.
Of course, my mouse has decided not to work, so we'll just see if I can make it work. My name is Laird. I work at a company called Laird Aerospace and Electronics.
Yeah. He was good guy. Okay, he retired. He retired Parkinson's.
Yes.
Can everybody hear me now? Excellent. So I've been working at Crane Aerospace and Electronics for about 12 years now. And about 10 years ago, some contractors were brought in to help us with a job. And they brought along this architecture they've been working on that they called ALOHA. So I can't claim that I invented this, but I did take it and run with it. I really like using it. One of the questions that came up in a previous talk today was, how do I know whether I should use this complicated thing or whether I should try and use my simpler thing? Well, I've been using this architecture long enough that I used it for all the simple things because it's so easy to use. It's easy for me because I've used it long enough. But what I also found out, because I'm training other people in how to use ALOHA, is that we can bring somebody in that's not CLAD, that's maybe used LabVIEW as part of their experiences when they're going through college, and I can have them creating the core type of module that this architecture calls an agent, and I can have them doing that in about a week. That's contributing to our productivity as a company. So even if they haven't used LabVIEW much, and they certainly haven't heard about ALOHA, they can be in and productive in a really short period of time. This talk is going to be focused on how we're using this in our company, but it is used elsewhere. I did an online search, Google like everybody else does, and I wanted to know where the heck this is used, and I found a whole lot of words in German. So I decided to use the magic of Google Translate, and they really like it too. They found it easy to use. It has a lot of functionality. It handles things that you don't really want to have to handle when you're designing your new program. You don't want to have to try and figure out how to do error handling or how to manage your different windows and how you want to load and unload stuff. All that's handled by the architecture for you. Let's see. If anybody's worked with other architectures, they can look at this and say, well, yeah, that looks just like everything else that I've seen. We've got some way for these modules to communicate back and forth. We call it the SmartCom protocol. It's just a text-based message handler. And text-based is important for us because we can have a really simple viewer. So we can see what kind of messages are flying around the system. And it's easy for us to figure out what might have gone wrong. If we've got something that's stuck in a loop and it's spamming the bus, we can see those kinds of things pretty easy. It's easy to expand. We typically generate these manual GUIs that run on our ATEs with 15 to 20 different agents in them. When this first came to our company, it took about 4 months to create a manual GUI. A lot of that was developing new agents. Agents are basically our hardware abstraction layer. So if we've got a new piece of equipment, we'll create a new agent, tell it how to talk to that equipment, and from then on, we've got that agent to use on all of our future programs. And that highlights one of the things that ALOHA is good at, in that it's easy to reuse things you've used previously. But it also means that if you're working for a business that has a lot of throughput with different pieces of equipment, you're constantly changing stuff out, this may not be the architecture for you. In our case, we tend to use the same equipment on ATE after ATE. So it's really useful for us. We can just pull all these agents that we've already created together, and they all work. The reason they work is because the architecture enforces specific rules. so that when you create an agent, you know that it'll work with all the other agents. So after we put stuff together, we'll end up with something that looks like this, or slightly like this, except I've redacted a bunch of stuff that I can show you. So each of these black bars at the top are a box that represents one agent. We've chosen to use these black bars, but this is just our style. The agent itself is really the code underneath the hood. If you go online to get the free copy of the ALOHA architecture, it doesn't come with these black bars. So we've taken this and we've, made it look the way we want to make it look. So, if you, as a new person to ALOHA, or even a seasoned developer, and you've looked at a bunch of different architectures, and you're like, well, I don't know, it's just another thing, I can try it. You probably want to know how easy it is to get moving on it. So I'm going to actually use it, which is, hopefully useful to you. You get to see how easy it is. And I have no idea if this is going to let me do what I want to do. Yay. So now you get to wait for my LabVIEW to load, which will probably take longer than I would like. I'll go with this. So, actually, rather than just starting with something that I've already created, I'll leave these agents here. It's just stuff that I pulled in because I thought it would be handy to have something to show.
Your connection there.
Oh my goodness! Okay, we're dead. She's dead, Jim. And now my screen is really small. Oh, and all of my icons went away. This is great. Okay, so the architecture is the thing that we use to build our application, but it isn't a collection of agents. The agents were built to work within the architecture. So I keep my agents in a separate folder. And whenever I want to create something, I'm just going to go into that folder. Should be something like this guy. And I'm just going to grab our generic manual GUI. Now it looks like it's got a whole bunch of stuff, but really I just need the VI. So I'm going to grab this guy, copy it there, and it'll probably break, just because, I'm presenting in front of 100 people. That's how that works. See if we can find everything. Well, normally it finds everything. This, of course, is taking forever. I suppose I could comment that bit out. I should find it. Yay. Yay, nowhere. And that's really big. And my mouse is touchy. Alright, so here's an agent. Doesn't look like it does much. When it started up, it went out to look for a file to define how it should load. Since it didn't find one, it just created one for me, which has some helpful stuff that's in it. And one of the things that's in here is a subfolder of where it's supposed to find the subagents that it's going to load. I'm going to direct it to that agents folder. And this time when it loads, it should find some agents. Let's see if it does. Did I miss something? That is, of course, what happens when I do this live. I didn't save. Thank you.
Did it overwrite when you closed the?
Oh, wait, you're right. So this is set to save true. So as soon as I closed this, it overwrote what I had in there with nothing. Good catch. Let's try it again. Okay, so now it's loading agents, which will take up some space. This agent is a TCP bridge. This allows us to talk to anything else that can talk ALOHA, which is, remember, just text strings. If you send text strings with the correct format, then an agent could receive that and take some action. It doesn't necessarily have to be any particular, the format is defined by the agent that's going to receive the string. We do have conventions for how we like it to be, but as long as you send a message that the agent can understand, it will get it. It's a broadcast message system, so every agent is going to get every message that goes into the system, and you're just going to filter out on the ones that you care about. That's one of the things that allows our manual GUI, our top-level agent, to respond to things that are sent by the UPS agent, for example, if it says the battery is low. I think I can do that. I'm going to simulate a UPS agent. That's the message. I'm going to send that, and I get my battery low indication. Yay. The other thing that this top-level agent does, which I may as well jump to the block diagram, which is going to be way too big to see. You should recognize this as a standard producer-consumer design pattern with events, with a string message queue. A little bit of stuff in the startup area. This is basically what we care about, agent startup. When we shut down, this guy does some stuff with battery critical. If I had sent that, then it would shut down my computer when I closed it down, so I'm glad I didn't send that. This is essentially what every agent looks like. It doesn't matter if this is this top-level GUI or if it's any of the sub-agents. They are all going to have the same kind of look and feel. And let's see, what did I call that guy? I can't remember, so I'll click a button. I'll say, oh yeah, where's she? Okay. So, diagram. We have this built into the architecture as well, so you can come along and look at a block diagram of anything that can receive a message. It's still the producer-consumer. In this case, we've got a third loop that handles all of our messaging. It's basically the same thing. Start up, shut down, producer-consumer. Oh, you can't see it over there. Not much to it. Anyway, all these look pretty much the same because they're all following the same rules of the ALOHA architecture. One of the things that came up in another talk today was moving stuff around and positioning and making sure that your GUI looks good. Well, at our company, we've decided that this looks good, so we're just going to make that our rule. You, of course, can make yours look however you like. If you decide that you want to move things around, this does give you the ability to control where stuff is and how big it is, and there's all sorts of things you can do that's built into the architecture. You can decide whether you want it in a floating panel. It will remember the sizes and positions of the floating panels. So as you pop things in and out, it will come back to where they were, and they'll remember that when you shut them down. In this case, the startup and shutdown is also handled by the architecture, so I don't have to worry about how to shut things down. I can just click this guy and it will shut down all of the sub-agents. which is kind of handy. I can add, I'm just going to pick something. I can add some controls. This is another thing that people find handy is bringing stuff in and out of any files. The architecture will take I think it's called Hungarian notation or whatever, a leading lowercase character, and it will know that you want that to be saved in the ini file. So now that I've added that, if I change the value, which of course is not a control, although I could, there are ways to change that anyways. I'm going to change it to a control real quick so that I can do this. Change, shut down, and change it back. So it should be in the ini file now, so that it automatically sets it to the state that it was when it was last shut down without error. Now, oh, and good, and I just hit that. It has all kinds of different methods of showing. In this case, I just told my console that I wanted it to be visible false, and I actually don't. So I'm going to change it back. You can also tell it what you want it to do when it gets a panel close. In this case, where's my close? Now, of course, I can't find it. No, it's not the close timeout. Now I'll have to go find it. You can tell it how you want it to respond to the big red X, as long as it's a sub-agent. If it's the top-level agent, it will always close the application. And where are you? And that is handled in the panel close event. So this is, with this blue bar on there, you might be able to see that as part of the agent class. These classes are kind of object-oriented light, if you will. You don't have to know a whole lot about classes in order to know how to use this architecture. It tries to handle all that for you. So for instance, there's not a whole lot of inheritance. There's no polymorphism that I can think of. And the classes are defining the interface. They're defining the rules of how an agent has to work. So when you use these, and this is a class instantiation, when you use these, it will just control how the thing operates, but not how it looks. And, so then, yeah, this panel closes a little bit different just because it's our top level GUI. Should probably have used a different example. Well, do you have any questions so far? I'm not seeing a whole lot of glazed looks, so I guess people are following. And I don't know what time it is. And of course, not sure why that happened. So, you may notice that the architecture loads based on a file and folder structure. I had pre-made this structure before I came here because I didn't want you guys to sit here watching me make it. But basically, I just dragged things out of my agents repo, and these agents have been developed over 5 or 8 years. So we've got 40 or so different agents that we draw upon. We get to improve them on each program, so every time we use the same power supply in a piece of equipment, we'll use that agent. The person who's writing the GUI may find a bug or a way to improve it. They can improve that agent, put it back in our repo, and then every future program gets that improvement. You'll notice that is not strictly object-oriented inheritance. This is a copy saved back into the repo. It's not the same thing. it makes it easier for us as a business because we can have CL80s and CLDs which run this architecture and create all of our software. It doesn't require CLA level people to manage this. The downside is that it doesn't have some of the fancy things that true object-oriented implementation can do. But we found in our business that that's not always necessary. Back to this guy. Ooh, wrong one. There we go. So, in order to add an agent, all we need to do is drag something in here and give it an ini file, which of course, we've got one here. And we need to make sure that it points to the correct folder. So this guy is going to be looking in. Oops. I think that's what I called it. F4_2, of course. And that's basically it. After we've copied something out of our repo and put it in here, the top level agent should be able to find it. Let's see. Yeah. And it should then load that after it finds all of its stuff. Ooh, that's really big. That's another thing, is that we can control what we want to show the user. If we want it to be really big or small or whatever, in this ini file, because we've defined for all of them, all of these are common to every ALOHA agent, and we have a subpanel and a floating dimensions, so we can have it remember that and just offer that to the user. In the VI properties, we would set the resizable files. And this guy gave me an error. Oh, well, oddly enough, I don't have any hardware here. So, so we probably got some errors related to I can't find my stuff when I tried to start up. And we are continuing to get errors every time the GUI loop tries to talk to the hardware. That's kind of expected. So as you can see, this handles all the error handling for you. It gives you a place to log them. It will log them automatically. There's actually 3 different places where errors are logged. The architecture itself will log errors to the desktop. Well, it'll log its startup and shutdown sequence to the desktop, and then it'll tell you about any errors. Or should probably, you can go away, and you can pop in, and I don't know where you're going to pop into, probably in a bad place. Yes, of course. And of course, all that can be adjusted if you don't like where it's at. Move you around. Somewhere. Anyway, it's pretty easy to build these applications. We can add a lot of functionality very quickly. How we use this at our company. This is the troubleshooting interface, as it were. So we'll have a stack of equipment. We'll have an agent, typically one agent for each chunk of equipment. And then that will only be available to the operator when they need to do troubleshooting. We have a different interface, which is very simple, that will talk to this using that TCP bridge and send it messages saying, I want to take a measurement from the DMM. And whatever DMM you happen to have loaded, this is our hardware abstraction, will go and get a measurement and return it, and then that can be handled by the calling program as an out of tolerance or just a log or whatever they want to do. It's all done through messages. And you can see these messages as they go through here. You don't have a whole lot to see because it's just loaded. And that lets you see during automation what's going on with all of the different agents all trying to work together. Like I said, we've been using this for 10 years. It's really been in this form for about 5 years, and it's really stable. The problems that we find are invariably problems with either broken hardware or a new agent. If we have a new developed agent that hasn't been through a lot of iterations, design cycles, reviews, then we'll find problems with them more often than anything else. But once you've used an agent a few times, you just keep using it. It doesn't break. It seems to work pretty well. And where am I at now? I wish my PowerPoint actually had worked because I had a bunch of comments to talk about and then I can't think of them. Any questions so far? Yes?
On this screen before, you mentioned that you can click on one of those bars on the left-hand side and allow you to move portions of the screen around. And you said that was part of the architecture. Is that part of ALOHA or something you've added?
The architecture enables it because all of this functionality is built into the architecture and this agent has leveraged that functionality. So the functionality is there. This is our implementation of that functionality. And actually I shouldn't say our because a variation of this was brought to us when we were first getting ALOHA. They already had some agents that they had developed. Console was one of them, control bars one of them. So they didn't come from us, although we probably improved them a bit. But yeah, the functionality is in ALOHA, but you can implement it in different ways. The functionality to pop stuff in and out has this pop button, but you can make the button look however you like because can I do that? Probably not. Because I want you bigger. When we start up, I'm looking in the upper left corner here for our startup stuff. So when we start up, way at the beginning, we fed a reference to the pop button as well as the error indicator into this cluster, which is managed by the architecture. So you could make some other pop button, feed its reference in here, and then it would act on that button click. So the architecture handles it, even though the implementation, in our case, looks like a little triangle. You can make it look any way you like. This particular agent console is where we typically like to see our errors. The error class in ALOHA is implemented as basically as a singleton, using our design patterns from previous lecture. And so any place that we want to wire in an error button or error indicator, which actually is a button, it will get handled the same way on all of those agents. And you can actually see that in the control bar because it has this little guy. That was how it implemented the error, which, oddly enough, handles things exactly the same way. But it's all handled by the architecture. Any other questions?
Is this?
Go ahead.
Is it? This is not compiled code. Do you normally use compiled code?
So we deploy compiled code. It runs the same way that this code runs. We, as was mentioned in prior talks, we do disable some of the functionality like this show block diagram when it's an executable. That's handled by the architecture. So in this show block diagram is done with scripting, and the scripting, that particular scripting node does not work. Maybe none of them work. when it's built as an executable. So we have to hide that button. Does that answer your question?
So,
Yes.
Laird, can you talk to the power of the console and the scripting interface?
So we have an agent that we've developed that sends messages, which you'll be able to see on console because console is an agent and it receives messages just like everybody else. Because an agent does not care where a message comes from, it could be coming from another agent, it could be coming from a button click on the front panel of that same agent, or it could be coming over a bridge agent, a TCP message that gets shuttled in. Because of that, we can have our scripting to control this GUI done any way that can send an ALOHA message, which is kind of a really broad way of saying that we can have something that's on the other end of the world, send a message through TCP, we can have test stand send a message. In our case, we also go through TCP. We can send a message by just writing it into console and clicking send, or we can click a button on a GUI somewhere. Well, this is just going to die a horrible death. And it will send a message, which we just saw. And, oh, it doesn't have a profile, so I can't run it. But it saw the message, F4, Wallow F4.start, and it replied with, hey, I got an error, and this is the possible reason. Instead of clicking the button on the agent, on the Wallow agent, I could also send the same message from here. And I would get the same response. The agent, the Wallow agent, doesn't know where that message came from. Whether it came from you clicking a button on it, whether it came from the console, whether it came from some TCP connection, doesn't matter. That allows us to have very flexible tool set. We have an Excel file which can send messages to ALOHA and get responses. We have a scripting agent, which is one of our agents that just talks on SmartCom bus. And of course, test stand, as I mentioned, also sends messages. All of these are treated the same way. There's no message priority based on the source of the message. Every message is treated the same way. The possible downside of that is if anybody's gotten into building architectures, it's pretty common to have a high priority message that gets shuttled to the front of the queue is the typical way of doing it. This does not do that. Every message comes in, it gets added to the queue, and it gets processed whenever it gets around to getting pulled out of the queue. There's no priority shutdown or anything like that. You can have a message which will shut down an agent, but the agent still is going to respond to its messages in the order that they're received. Did that answer your question?
Yeah.
Because a little more of a question is more like a statement. Do you have any other questions? What time is it? Do I have time left? It's getting close to my 50.
So, Laird, maybe you can paint a picture of the contrast of how much faster we can stand up ETE now for development guys to be able to use as compared to what we used to do before we had ALOHA.
So when ALOHA first arrived, I mentioned that it took about 4 months to do activity. It's typical right now if we have no new agents that need to be developed, we're just using stuff from our archive, I can get 15 to 20 agent GUI going in about a week. And that's just me, no other developers, one person, 1 week. It will have all the functionality that's built into the agents already, which in some cases is considerable. And it will already have a known interface. So when we do integration, people will already know how to talk to it. It will already have known characteristics, like how long it takes to take a measurement to respond, or what it's even capable of doing. That allows the systems group to request functionality. If they already know that it doesn't do this and they want it, they can ask it early in the development process because they know that it's a need. And they already know what our agents do. If I was pressed, I could probably get a GUI going in a day or two. Might be a little rough. When I click the close button, instead of popping in, it might just totally disappear because it went visible false. That's the default for clicking the close button. Let's see what this does. Yes, visible false. So there's little details and cleanup, and it takes a while to flush out all of those little idiosyncrasies that you want to clean up. But it can be done in a very short period of time. Some people have asked whether you could just use a library. We've already got LabVIEW libraries. Why not just have a library? We can use that. It already controls the equipment. Well, one of the things that this does that a library doesn't is it has sort of a macro functionality where you can have one button on the agent, send a bunch of messages, get a bunch of responses, compile some data, and produce a result. That is really difficult and might even be impossible in a library. It also comes with its own GUI. I mean, when you build these, it basically builds this manual GUI for you. So you don't have to redo the build of the GUI. Whereas if you had a DLL and you wanted to reuse this DLL, that's great, but where's the GUI? Well, you got to build your GUI again. So this is sort of like a DLL with a GUI built in. I don't know, we've had a lot of success with it. It works great for us. It's pretty easy to get started. It doesn't matter whether you've got this top level agent. You can go into the sub-agents. Let's get a console. There's my console BI. And I can just run him by himself. Now what just happened is the console agent went to look to see who its owner was, and that was non-existent. And he went, oh, I guess I'm the top level agent. So it created the application object, it created the error handler object, it created everything that it needs to run. And then it went into its ini file and said, okay, do I have any sub-agents? And that was empty. So it said, okay, I'm done. And it just hung out. This lets us, if we were using a piece of equipment, it lets us start up the equipment agent without the entire manual GUI. All we need to do is start just that one agent. It will connect to the equipment. Yes. And it will also start up everything that the architecture knows that it needs for it to start up. So I don't have to have any particular top-level agent. This is basically just a container to hold everybody that I want to display. And I could just run this, do some troubleshooting, maybe work with just that one piece of equipment until I get this agent working the way I want. And typically we do that while we're developing the agents. We just run them by themselves. It'll talk to the equipment, we'll work with it. And I don't want all the overhead of the other 39 agents in the whole system all trying to run at the same time. I just want to work with him. And you can do that. It runs by itself. It knows that it's a top-level agent, so you can't pop it into anywhere, so it hides the pop button for you. And it has the error handler, so it will do all of its own stuff all by itself. It's really easy to develop and it's fast. You have lots of questions. What's that?
I'm trying to suggest some things for you to.
Okay, thank you.
So, how might this architecture be used to help you develop your software before you have instruments or hardware to talk to?
So, this does not have built-in simulation all by itself. The architecture does not do that. You would have to build that into the agent. If the drivers came with, I forget what type of drivers, if the driver was a IVI driver, they have built-in simulation, you could use that. But ALOHA does not handle simulated equipment. It needs equipment to talk to. You can certainly say, well, if you can't find your equipment, then just disable everything. But it doesn't simulate stuff by itself, just because of the architecture. Okay, I think that's about it. Yeah, about out of time anyways. Yes.
All I was going to say, can you speak a little bit to integrating this with testing?
I can. The biggest takeaway for integration with test stand is that you need some way for test stand to send a message over TCP to you can go away. Don't save. Moving on forward. So we use this bridge TCP agent. This is what manages all of the TCP connections. So you have to be able to make a connection to this agent. It has a known service, the LabVIEW or TCP service. You just put that in and make a connection and then send messages, it's just text. As long as an agent understands the message, it'll respond and you will get a reply over TCP and you can handle it. That is all the test stand is doing. It's opening a connection at the beginning of the test. It's sending messages throughout the test, getting all the responses and determining pass-fail, and closing the connection at the end. You can run multiple threads. You can make multiple connections to the TCP bridge. It doesn't have any problems with that. We've had, I think, 8 connections, simultaneous connections so far. Everybody talking, all 8 connections doing stuff. It doesn't have a problem with it. That's the integration with test stand. And it would be the same as integration with anything else. If you had your own scripting methodology, all you'd have to do is create a TCP connection and send those messages, and this will get it and act on them. Any other questions? Okay, that's the end of the presentation. Thank you all for showing up.